Okay, this is a Hess law problem. It happens to be out of an old text, but when we look at it, the easiest way to work a Hess law problem is to follow it through from left to right. This is the original equation we're looking at. So the first species we're looking at is the methane. Now, that means this is the reaction that has the methane in it, but I need to flip it. So this one's going to be flipped. So when I rewrite it, man, I only need one methane, so we're good. So we've got methane, and when I do this, I'm going to try to align the arrows, so I'll kind of start in the center. Is carbon solid plus 2 hydrogen, and this happens to be a gas. Usually you don't need the states, but I'm going to go ahead and write them here. So if I flip the equation, I flipped the amount. So it moves to 74.6 kilojoules, and it's gone from a negative to a positive. Okay? Now, the next species, so I've taken care of that one. So I'm looking at chlorine, which this one has chlorine in it and has the added bonus of having carbon tetrachloride. So we're going to leave that one as is. So I got carbon tetrachloride gas, and I have 2 chlorine gases plus a carbon solid. Since I left it alone, I'm going to leave, the sign alone, and I didn't do that. So let me erase that, and minus 95.7 kilojoules. So I have a positive and I have a negative. So then I'm good there, and now I need the hydrochloric acid. So this last one is going to stay the same, except I need 2 times it, so I'm going to double it. So again, I'm going to leave my arrow alone. Now I have 2 hydrogens and 2 chlorides and 4 HCl's. And because I didn't flip it, the sign stays the same, but I did double it, so I get 184.6 kilojoules. Now, once I total this and I look at it, my carbons canceled. I had 2 chlorines and 2 chlorines as fluorides. The hydrogens canceled, so I'm left with methane plus 4 diatomic chlorines yields carbon tetrachloride plus 4 HCl's. That's exactly what I wanted. So when I add these together, I'm going to get minus 205.7 kilojoules. Now all of those were one place after the decimal, so my answer is the same. And then the question is it endothermic or exothermic? Well, we look at the sign. Since the sign is negative, it's exothermic. If it was positive, it would have been endothermic. Now, Hess law problems pretty much all work the same way. You flip some, you multiply, you divide, whatever you need to get to the goal